We've had a lot of questions lately about how to handle change in volume and change in area type questions. So what I wanted to do is to number one, try out a new piece of software, and number two, try to make a video about how to handle these type questions. So we'll just start with excuse me, this question. If the length of each side of the square below were multiplied by 7, how many times greater would the area of the new square be? What typically students would like to do is just to say, well, the area would simply be 7 times greater than this. Well, first off, let's calculate the area of this square. If we notice that this side length is 4 and this side length is 4, to find the area of the square, we would just say area equals side squared. In this case, it would be area equals 4 squared, which is 16. And what many times students like to do or want to do is just to simply say, for the new square, we would just say 16 times 7, and that would be 112. But we have to kind of think about some things here about what is actually being multiplied by 7. So let's look at a new square and kind of think about this. If we were to expand this square, now notice this is not going to be to scale, but what is actually going to be 7 times larger? If we think about it, this side length is going to be 7 times larger, and this side length is going to be 7 times larger. So how much larger is this square compared to this square? The square on the right is actually going to be 7 squared larger because the side lengths both are being multiplied 7 times 7. So this square is actually going to be 49 times larger. Now, if we need to see some numbers to kind of back that up, let's just go ahead and find the area of this new square. We can multiply. If this one is going to be 7 times larger, then that means the new side length is going to be 7 times 4, which is 28. And this one would be 7 times 4, which is going to be 28 as well. And so to find the area of the new square, all we would have to do is multiply 28 times 28 to see that area is going to be 784. So the area of this square would be 28 times 28, to get 784. Well, we can kind of prove this to make sure that this is all correct by taking the area of the new square, which is 7 times larger, 784, and dividing it by the area of the previous square, which is 16. And if we notice, when we divide 784 divided by 16, we get 49, which is which is what we have here as the area of the new square. Students a lot of times make the mistake of forgetting that in area we're dealing with 2 dimensions. We're dealing with length and we're dealing with width. So we have to multiply 7 to the second power because the scale factor is 7. In our class notes that we have in our notebooks, I had students make sure they write down, and this you can even find this on the my website too under some notes, is that what we need to do is if we know the scale factor, in this case it was 7 times, all we would have to do is take the area 16 times the scale factor squared, and we take 16 times 49, and if we do that, we find that 16 times 49 is 784. If the question were, what's the area of the new square be? In this case, the question is just asking how many times greater. Well, it would be 49 times greater than the area of the new square. So let's look at another of these type questions. It says here that Pamela's backyard deck is shaped like a rectangle and has the area shown below. If the dimensions of the deck are doubled, what will the new area in square feet be? Well, once again, and test makers know this, that students would just typically, what they would like to do is just say 140 times 2 to get 280. Well, we got to think about our thinking here. What is it that's actually being doubled? And if we take a rectangle, and once again, let me expand it to just kind of show that we're doubling the dimensions. What is actually being doubled? We can see that this side length is going to be 2 times larger, and this side length is going to be 2 times larger. So in essence, this whole rectangle now is not going to be 2 times larger, but the rectangle itself is going to be 4 times larger. So really what we could do is we could take 140 times the scale factor, which is 2, squared, which is 140, and 2 times 2 is 4, and 140 times 4 equals 560. Now, not 280, and that's the fallacy that a lot of students make. So let's kind of think about this with some real numbers, and just to kind of prove our point here. Let's take this rectangle. This one is the original right up here, and we know that this one is 140 square feet. Well, let's put some actual dimensions with it just to kind of clear things up. Let's say that this side length is 10, and let's say that this one is 14. Let me take this same rectangle, and let's say that this one is doubled, and so if we label if we label those side lengths, we would see that instead of 10, now this one would be 20, and instead of 14, this one would be 28. Now to find the overall area of this rectangle, we would just multiply 28 times 20 and see that that comes out, that area comes out to be 560. Whoops, sorry. So when we think about doubling any dimensions with area, and this is the key. Right here it says square feet, which tells me what the exponent should be. The exponent should be 2 with area. Now, looking at the next question, we kind of get into a volume situation. And the thinking is the same, but we have to do something just a bit different. A department store has 2 different size bags for their customers' purchases. The bags are shaped like rectangular prisms when they are open. The smaller bag has a volume of 1,200 cubic inches, and if the dimensions of the larger bag are twice those of the smaller bag, what is the volume in cubic inches of the larger bag? Now, once again, what we'd like to think is all I have to do is to take 1,200 times 2, because all I'm going to do is just double that volume, right? Well, no. What is it that we are actually doubling? That's what we have to think about. And this thinking is typical, but we have to really go back and think about what is volume. And I said a while ago with area, I want to think about the unit. It's a square unit. With our with volume, it's a cubic unit, because what is actually 2 times larger? We see that this is 2 times larger, this is 2 times larger, and the height is 2 times larger. So in essence, this whole volume is going to be 8 times larger. 2 times 2 times 2 is where I get this concept, this number 8. So in order to solve this, we would take the volume of the small sack, multiply it times the scale factor, in this case it's 2, to the 3rd power, because we have 3 dimensions with volume. And once again, I go back to that unit, cubic inches. And so all we have to do now is to go ahead and multiply 1,200 times 8 to see that that is a new volume of 9,600 centimeters cubed. So in volume type questions, we just have to remember that we have three dimensions that we're dealing with. We're dealing with length, and we're dealing with height, and we're dealing with width. Here's just one more same type problem. A cardboard company, or a company uses a cardboard box with dimensions shown to ship products in the mail. The company also uses a box with the dimensions that are 5 times greater than the dimensions of this box. How many times greater will the volume of the larger box be? Well, we got to, once again, in the new box, what is going to be 5 times greater? We can see that in the new box that the length is going to be 5 times greater, the width is going to be 5 times greater, and the height is going to be 5 times greater as well. So the new box, the new volume is going to be 5 to the third power. So the new volume is going to be 125 times greater. And I get that by taking the scale factor to the third power, because it's a volume question. Now we can kind of go ahead and show and prove that. Let's find the volume here real quick. Volume equals length times width times height. Volume equals 10 times 5 times 5. And volume equals 250. And this the unit was, gosh, it doesn't say. So this is units cubed. Well, if I wanted to find the volume of the new box, it would be length times width times height. But remember, we're doing 5 times, so this would be 10 times 5 times 5 times 5 times 5 times 5, because the numbers, the 5 in the parentheses, is scale factor. So if I multiply 50 times 25 times 25, that equals 31,250. To find the change in volume, to see that this 125 is the correct answer, we would take 31,250, which is the volume of the new box, divided by 250, which is the volume of the old box, and see that it is in fact 125 times larger. I know there's not just a great deal of information out there on the web as you're looking, and our books aren't a great help, and I hope that this video helps clear some of that up. There's still the scale factor part. I want to do a few problems with that, but this video is kind of like a pilot. I want to try this out and see if I can post it on the web and see if you can get some help at home and those type things. And if this is successful, I can plan on continue doing more of these type videos. So thank you so much, and please check my website for any changes, for any additional help that you might find, class notes and information. Thank you.